Okay, geographers, this time we're going to be talking about science, what science is, what science isn't. So last time we talked about geography, and I got into what geography is all about. We talked about spatial, the idea of conducting spatial analysis and all of that. So you hopefully have a good idea about what geography is. Now we're going to get into science because you are taking this class to fulfill a physical science requirement. Um, as is always the case, many of you are not science majors or geography majors or whatever yet, right? We'll fix you. But it's important for you to really have a firm understanding of what science is as once you leave this class. Hopefully that'll be one thing you have that you take with you, so you have a better sense of what scientists do, how people who do science actually solve problems and answer questions and stuff like that. So I'll spend time on just that concept of science, and that will lead to a discussion of the scientific method, which I know you guys have all heard about since, I don't know, first grade, second grade, whatever it might be, or, Sesame Street or something like that. We all hear about this stuff. So some of this will be review for you, but I'm also going to show you how the scientific method and how just scientific research in general moves forward in a realistic way. A lot of the ways in which we introduce you to science and all that, it's very abstract. It's done in a way that isn't actually practical. So I'm going to make this actually mean something for you, hopefully, anyway. And so we'll get into that. And then I'll also get into this idea of the field sciences, this image you see on the screen right now. These are some former students of mine from a class I teach where we head out, we learn field methods, how to use maps and GPS and stuff like that, and actually learn how to go out and do stuff, actually, record data and gather information and things like that out in the real world. Because that's another thing that I think we don't do a good job of explaining so often when we're describing science and scientists. We evoke these images of people in a lab, in lab coats and goggles, and they're just mixing liquids in beakers or whatever. No, no. I don't want you to think of science in that way at all. I mean, there are people who do it. Great, bless their hearts, those chemists and people who like working in labs. But for geographers, those who go into physical geography, they enjoy science and scientific analysis and the stuff that we get into, but they also don't want to be confined into a lab or confined to be wearing a lab coat and all that. No, lab coats are the worst. Absolute worst. No, you want to have real big kid clothes that you wear out into the real world and you get dirty and you play around with that. So we'll talk about field sciences and what geographers do and all of that. All right, so that is the plan here. So to start with, got this definition of science here: the systematic study of the world around us. And in that sentence, what is the key word here? You look at that. I hate this. I mean, I'm still, even though this thing is remote, I'm still going to ask you questions that I would be asking you if you were in a classroom with me. So just, go with it. Play along at home. I'm assuming all of you are sitting like at a desk, earbuds in, and you're hearing this. And as soon as I say, "What is the most important word here?" your hands go straight up and you're shouting out, just into the kitchen or whatever. I'm assuming that's what's happening. The 6 of you who are actually taking the time to listen to this. So, class, what's the word? It's hopefully what you're thinking, is systematic. That's the key thing. that, to study the world, anyone can study the world, anyone can study nature, or whatever it might be, in a variety of ways. And it kind of goes back, like what I said last time about geography meaning to describe the earth, and how, like, a poet can describe the earth. Other people can describe the earth, and they're not necessarily doing geographic work, right? They're not necessarily geographers. Same thing with science. We can study the world, but if we're not doing it in a very systematic way, and that's, for the most part, the scientific method stuff that we'll talk about. I'll get into that idea of systems. If you're not doing that, you're not doing science. Okay, so systematic, that's key. And I'll elaborate. But then I have these other two terms down here, and these are equally important. Verifiable means people need to be able to verify my work that I do. Okay, so if I'm doing some science, I'm doing some kind of scientific research, and I go out and I do this stuff, and I say, Eureka, and I discover something, or learn how something works, or whatever, I need to be clear about what it is I did. I need to document that. I need to share my methods with other people. That system, right? That systematic study. Other scientists need to be able to look at that and see what I did, so they can say, okay, yeah, that makes sense. Oh, yeah, I see what he did there. And okay, well, of course, yes, that's why he would figure this out, or learn this, or, whatever. If I'm not sharing that, then no one has any idea whether I did something truly scientific, or if I'm just making stuff up, or whatever. All right, so verifiable means others need to be able to verify that work. They need to be able to make sure that that work is correct and proper and done well, and all of that. Okay? And then underneath that word, we have repeatable, another key term here, meaning that any type of scientific work that I do, anybody else should be able to do that as well, follow that same systematic approach, do the same stuff, gather the same data, analyze it in the same way, all of that. They need to do that, and not just be able to do that, but get the exact same results, right? Every single time, to make sure that it's not some fluke. It's not that I just, I got lucky and it looks like I proved something even though I didn't, and it's because of some variable I didn't even think about, or whatever, right? So it's got to be verifiable. People have to be able to see what I did, but then they also need to be able to go in, do that same thing, repeat those experiments, the analysis, whatever it might be, and get the exact same results. Okay, so that is key. And if you don't have that, then you don't have science, right? And so this, and in part, what I'm talking about here too, like, I want you guys to get a sense of what science is, but as I said, many of you are not science majors, let alone geography majors or whatever. I think we talked about this last time. You've made horrible choices doing your business or English or sociology. But, and again, I'm not here to judge. I think all of you are wonderful little superstars, and I'm here for you. A safe learning environment, all of that. So what I'm saying is, you don't, science. You might think like, oh, why do I even care about science? Why do I need to know the scientific method and all that? Here's the deal. Science is kind of, I don't know, kind of a big deal. Have you guys heard about this whole coronavirus thing, the whole COVID-19 thing? Are you familiar with that at all? That, to defeat it, we're going to need some science, right? We're going to need people doing the research to understand this virus, get a sense of how it works, to be able to develop a vaccine, be able to do, whatever it is that these people who study that stuff do, right? You don't need to know exactly how the viruses work and all that stuff, but what we should have a sense of is just this concept of, what is actually, a scientific approach and what isn't. And that way, when someone makes some claim about, aha, I figured out a way to defeat the coronavirus, or when, people say stuff like, well, it's warming up, that should kill the virus, and, things like that, we need to be able to immediately take that information in, question it, right? And start to question. Again, if I don't understand fully how viruses work, which, just between you and me, I don't understand that. So I'm not a medical guy. I don't study all that, but I have a sense of how scientific research works, and how to look at studies where people have done this stuff, so we can make these claims and say, oh, okay, yeah, this all seems legitimate, versus stuff that's questionable, right? Things that we can't necessarily verify, things that have yet to be repeated, and all of that, right? So think of this as we're going through. Think of this as, you are citizens of the earth. You're here. There's, a lot of scary stuff happening right now. And you need to be able to process the information necessary to deal with it. Right? And this also gets into, other stuff at work. It doesn't have to even be scientific, it's just information in general about whatever political, social, cultural, whatever stuff is coming in. It all works the same way, more or less. And I'll explain some of that as we go on as well. So that's why I'm subjecting you guys to this. This is why you should want to learn this stuff. It's so you can actually be, intelligent and make informed decisions and filter through all the crap that comes flying at us all the time. All right? Okay, so that's the idea. All right, there's a little pep talk. Now, another thing here we should get into is just this idea of, like verifiable, repeatable, all that, blah, blah, blah. That works. But even then, we can still have stuff that seems to meet the criteria, but it still isn't really science, right? And so that it can be challenging. And really, all this it's critical thinking, right? Think about that lady driving to Croatia, right? We're taking in this stuff. We have to keep questioning it, make sure we don't make a horrible mistake, drive all the way to Croatia. So right here, I mean, a clue that this is all crap that we're looking at on the screen is my heading that says what science isn't. But if you look at this diagram, this image, it looks pretty sciencey. I mean, you got water, right? So it says there is only 110 highest pH in the industry, and you've got all these bottles of water lined up, and then you have their pH values listed at the bottom. All right, you know what pH is? You familiar with pH? It's it's got to be sciencey, right? I mean, just look at it. It's got that little p, big H. I mean, who would do that other than a science? That is just, it's got numbers. That's very, very STEM like. STEM, which is something. See, this is why I wish I was in a classroom with you guys, because I love to ask you students what is STEM, and you repeat it, but in like this sad, broken kind of way: science, technology, engineering, math. STEM is garbage. We'll get into that too. It's not the concept of science and math and all that. That's not garbage, but it's the way it's STEM, right? When we put it together in this cute little acronym and all that, that'll be the death of us all. All right, so all right, I'm worked up here. You can tell. Yeah. Okay. Let's go back to the water. Right. I'll yell at the STEM people later. I'll yell at all sorts of people later. Get ready. It's going to be a wonderful semester of yelling at varieties of people. All right, so we're looking at the water. It's got the pH. Look, here's the deal with pH. Right? It's a scale, all right, where we're looking at if something, any substance out there, is either acidic, all right, or neutral, meaning it's not acidic nor anything else, or alkaline. There, we also use the term base or basic. All right, and so with acidic, like if I say acid, we have a sense of what that means, right? So we can picture that. Alkaline can get kind of fuzzy. In the instances we're going to use it in this class, you can think of it as connected to salt. Okay, and all this stuff has to do with like hydrogen ions and all this chemistry stuff. We don't need to worry about it. Let the chemists worry about exactly what's going on. But the idea is we have stuff that's acidic, right? An acid. We have stuff that's alkaline, which means it's like salty. And then we have stuff that's neutral, meaning it's neither of those. It's in the middle. And this scale goes from 0 to 14. So 7 in the middle is neutral. And then anything less than 7 is going to be acidic, or we refer to it as having a low pH. Okay, and so the lower the number is, the further down you get from 7, the more acidic it is, right? So like a 0.1 or whatever would be incredibly acidic, whereas a 6.9, it's technically acidic, but not that big a deal, right? And then anything above 7, like a 7.1 up to 14, that's going to be alkaline, right? That's the idea here. And so we have this, what it's showing is that if you buy bottled water, you're going to get water with different pHs. Are you aware of this? Do you pay attention to this? Are you drinking water right now? Are you? Be careful. Spit that water out. Spit it out until you understand exactly what we're getting into right here, right? My God, you're so dangerous. So yeah, you got to know your pH. And here's why you got to know your pH. It seems to be, as best I can tell, it goes back to some lady who did a science fair project with her kid at school. And it seems like the lady was really the one doing the science fair project, which is how a lot of these science fair projects go, of course, right? Because you need your little special child to be number one, even if you're doing all the work. I'm a parent, I get it. I just don't have the interest in, in making my kid number one because I got stuff to do. So this mom is helping the kid with the science fair. What they did was they got a bunch of different brands of bottled water, and then they got litmus paper, which is something you use to test pH. You guys probably, hopefully, did this in like a high school science class or whatever. You're testing the pH level of, whatever it might be. And you do this like with if you have a pool, you're testing the water. You're testing the pH of the water. So you can get these supplies like pool supply stores. And that's where, this lady got the stuff to be able to test this water. And so they did, and they go through and they systematically, and it's all verifiable because I'm able to explain it to you. So they go through here and they get these bottles of water and they find, much like this ad for Alkalife is showing us here, they find totally different pHs for every bottle of water. Okay, so far, so good. And the idea too, the reason I know about this is because it went to social media, and I had another student ask me about it, and they weren't really interested in, like pH. It wasn't like some, nerd student who was like, pH is cool, I want to learn more. No, it was a woman who came to me totally freaked out about this stuff. He's like, I gotta test my water. How do I get the water strips? I gotta test it. She was freaking out about her water. And it's because with the science fair thing, it wasn't just like testing the pH of water. Instead, they took it a step further. Okay? So they analyzed their results. So everything up until the analysis was going fine. It met our criteria for science. The problem was it was just the logic used, the reasoning used, not the best. Kind of went to a leap. And the whole idea was they connected this low pH and acidity to antioxidants and free radicals in the human body and all of that. And so their conclusions for this study were that the water with low pH causes cancer. You follow? So if you look at this is where I said spit your water out. You fools! Is anybody drinking Arrowhead? Oh, spit it out. Or Dasani or Aquafina Propel Zero. I hope you don't have some of that cancer-causing Propel Zero. Because that's bad. No, what you need to do, you know what I would do to make sure I get the least amount of cancer? I would go to Alkalife. Alkalife 10, a pH of 10. Right? To make sure it's not putting a little cancer in me as I'm drinking it. Yeah. What's the problem with that? Is that a thing? Do we have to worry about cancer water? We do, but not in this case, right? We'll get into water quality later on. But is this a thing? If you drink Aquafina or Propel Zero, are you doomed? No. No, how do we know this? Think about this. Hopefully, if you process this for a little bit, you can kind of start to piece together what's wrong with this line of reasoning, right? So I'll wait. You can pause it, I guess, if you want to puzzle this out yourself. But just think about it. As you drink this water, whether it is Propel Zero or Alkalife 10 or anything in between, where's that water going to go when you drink it? You're gonna tilt it back and you're gonna drink it, and it's gonna go into your mouth and in your throat, and then where? In your tummy, right? And what's in our tummies besides that delicious water? Acid, right? Stomach acid, something that is incredibly acidic, has an incredibly low pH. So that kind of, just that leap to taking something that has a low pH and drinking it, and that's gonna kill you immediately. That's a reach. Also, you can think about, have you ever had lemonade or orange juice or coffee or anything like that? Have you? You have? Animals. That's cancer drinks. No, that's ludicrous. And so when you think about it, through it a little bit and you start to poke holes, you realize, oh, this doesn't make any sense at all. But it was this, so like, I think it was like a Facebook post that came up and it had all this, and a lot of people went, oh no, we're drinking awful water, we're all going to die. And then it seems to be that these water companies just seized on it, right? And decided to make more alkaline water so that we would feel safer or whatever. And you notice this doesn't actually say anything like why you should want to have a pH of 10 in your water. And also, honestly, I don't know. I've never had Alkalife 10. I'm sure it's delicious. I've had some of this other stuff that technically has the high pH, but honestly, like if you're really worried, just go down to the ocean and drink seawater, right? And then, I'm sure that'll be healthy as can be. Don't actually do that. Put this in your notes. Don't drink seawater. Maybe we'll talk about that later. But it's yucky. But that has that high pH, right, compared to this other stuff. So the point here is some stuff can look very scientific, but what we need to do is just kind of look at it and pause and question and go, wait a second, what is it actually saying? Or wait a second, how do they actually come to these conclusions or whatever? And you find with like advertising, especially, you have a lot of stuff that looks incredibly scientific. I mean, look at that little P big H. That looks super scientific. But you notice they don't actually say anything here. They don't say why you should be drinking this pH 10 water and not the other stuff, but they just kind of imply that you'd be a fool not to. Right? Think about that. And this is getting into why we need to know, what science is and what it isn't and how this stuff works so we can just be smarter. Again, whether it means we're listening to the right people about how to deal with pandemics and disease and stuff like that, or just when we're at the store and we're looking at stuff to buy, or we're flipping through a magazine or online or whatever it might be, we see these ads and the packaging and all that, and we're not duped into buying something stupid, right? Unless you want it. If this the whole Alkalife 10 thing, and if that's your water, if that's what you drink, if that's your thing, you keep rocking on. You keep doing it. I'm not here to tell you what to do or what not to do, but just realize everybody's gonna look at you and think, "What a fool." Yeah, exactly. Right? Yeah, I don't know. Drink whatever. Drink it if you got it. Let's move on. All right, now we have a sense of what science is and isn't, and we have our definition. Now let's get into how we apply it. And really, with science, it's not a thing or an object, or it's not the equipment, whether it's litmus paper to test, pH, or beakers or Bunsen burners or a magnifying glass, or like whatever. It's not that. Science is a way of thinking, right? We do scientific reasoning. So we're intelligently questioning things, trying to figure stuff out, trying to come up with answers, solving, problems. And whenever I say problems, I don't know if I got into this last time in the last lecture, but a problem really just means some kind of question, something we don't have an answer for, right? Or don't have a satisfactory answer for. Okay? So problem doesn't mean bad. Think of it more like a math problem. We use it the same way for in a math class where it's something that doesn't yet have an answer. So we come upon it and we go, huh, that's interesting. I wonder what's going on here. And we try to solve that problem. We try to get that answer. And we found over the centuries that quite often the best way to solve certain types of problems are through scientific reasoning. And you note I'm very specific there. Certain types of problems, absolutely. Science is fantastic. Other ones, not so much, right? And this gets into like what I got into last time with human geography or cultural geography, as we call it at ABC, and physical geography. We still use spatial analysis, and we're similar in that way. But in cultural geography, like Geography 105, offered in the fall, in spring, always at ABC. Sign up, enjoy. We deal with this stuff, at least I do, when I teach the class. I deal with this stuff where science isn't helpful at all, right? Things like racism is one I talk about a lot, and we spend time on, but we don't get into the scientific basis of race and all that. I mean, I talk about that a little bit to get it out of the way, but we find that like science isn't going to stop racism. All right? No offense, scientists, bless your hearts. You're not going to solve it because there's other stuff, other messier human things at work. Right? So just be clear about that. Science isn't perfect. It's not always the solution to every single problem that exists. But when it comes to just figuring out how the natural world works, when it comes to figuring out, just basic principles of matter around the planets and out in the universe and all that, it's the best. It works wonderfully. Okay? And so that's what we're going to be focusing on here. Now, when we're doing this scientific reasoning, we have a few different ways we can approach things. And it all depends on how the problem is set up and what exactly is going on here. We can do either deductive reasoning or inductive reasoning. Okay, now on here, on your screen, I have these two definitions. I didn't come up with these. These are classic ways to explain the difference between deductive and inductive. So deductive, working from the general to the specific. Okay? And inductive is working from the specific to the general. Does that make sense? Of course not. See, these are great. They make perfect sense if you already know what these words mean. But if you're completely new to them, you're trying to make sense of it, you look at it like, wait, what? Because it's so vague. So this works, trust me, but you got to know how it works before you can see that it works. So let me explain. Let's work through this. And I'll give an example of deductive reasoning to begin with. And what I always like to do with classes is, we don't get into all this nerdy science nonsense. We get into the good, sexy stuff. So let's picture like the good old days being back on campus, in a classroom doing this face-to-face instruction. And let's say like you're all waiting out in front of the classroom like good students, waiting for me, your instructor, to come to the classroom, open up the door for you. And I do that, and we all go in together, and there's a dead body right there in the classroom, just the middle of the classroom, dead body. What are we gonna do, class? See, and if we're asking you like in real life, and we're talking about this, it's like, what are we gonna do? And you'd be like, call the cops. No, no, we're not gonna call the cops. We have a variety of reasons not to call them, but the real reason we're not gonna do it is because you know what? We are people of science, right? We are geographers. Well, I am. You guys are almost there. It's going to take a few more lectures, and then you'll get there. But I am a geographer. I am a man of science. I can figure this out on my own. I don't need the police. I've got my brain, right? I can think. So, okay, let's say we're not going to involve the cops on this dead body thing, which is always it's always a smart move. Put this in your notes. In reality, if you do come across a dead body, call the cops. Right? Don't. Okay. Yeah. But let's just say we're not going to call the cops. So what are we going to do? How are we going to solve this, my little crime busters? What are we going to look for? Clues, right? You can't solve a crime, some mystery, without clues. So that's what we're going to be looking for. And what kind of clues could we look for? All right. And again, whenever because I always ask this to students because it amuses me. Like, what kind of clues do we need if we got a dead body in the classroom? Students will always say, like, the first thing is like, find the murder weapon and stuff like that. Is so not interesting. Like, who cares? The guy's dead, right? Does it matter if he was stabbed or shot or whatever? No. All right. What? No. What we want to catch the bad guy. That's what we're interested in. Now, how can we tie a specific individual to this specific crime? All right. We got DNA. We got fingerprints, and they both effectively work the same way. Let's just go with fingerprints here. All right, so we're going to look for fingerprints. But why? Why are we looking for fingerprints? Because that's what they do on TV shows and stuff, cop shows. They look for fingerprints. Yeah. Okay, so that might be. But why would cops look for that? Why would detectives wouldn't even find fingerprints? How do fingerprints work in this case? And as I'm saying this, you're probably thinking, like, what's wrong with this guy? But I'm saying it like I know how fingerprints work, but you need to think about that, right? Like, why would we look for fingerprints? What's the reason, right? Can you put that into your own words? And the reason is, of course, because fingerprints are unique, right? We know that humans have fingerprints. We have these ridges on our fingers, and due to, oils in our skin and all sorts of other stuff, we can leave marks that leave the actual, the look of our fingerprints, the little picture of our fingerprints on something, on some surface at the crime scene. And that's so that when the folks dust for prints, the dust picks up these fingerprints. They can take a picture or transfer the dust itself with tape or however they're going to do it. They can extract these fingerprints and then be able to compare that to suspects. And so if they find someone's fingerprints at the scene of the crime, right, and then you find that person, it's got to be that person, because nobody else has those fingerprints. So that's your murderer, right? But right there, what we're doing is deductive reasoning. Okay, we're working from the general or general knowledge. Okay, an already known thing. Fingerprints are unique. Okay, that's already figured out. We're using that to explain a specific problem, some local event, some local mystery or whatever. So that specific crime scene. All right, so the general in this case, what we're talking about is just generally known knowledge, already proven scientific knowledge. Like fingerprints are unique. Okay? And then specific means that thing, that problem, whatever it might be that you're faced with, where you just go, I don't know what's going on here. Or, there's a crime, I need to solve it, or whatever it might be. All right? So that's how deductive reasoning works. Hopefully that makes sense. And as always, with this stuff, as I'm going through it, if it doesn't make sense, we'll go back and listen to it again. Make sure you just didn't, miss something or slow down my words to make you sound drunk or whatever to help out. If it's still not clicking, feel free to contact me. Get a hold of me if you want to, arrange for some kind of office hour visit thing through Zoom or Google Meet or whatever. Happy to do that. We'll get through this stuff. I want you guys to get, all of this stuff. I'm teaching it for a reason. All right. So that's the idea here. Okay. So that's deductive reasoning. Going from the general, already known knowledge to explain that specific thing. Okay. Now, inductive, this other one, it's the opposite, working from the specific to the general. Okay. So in this case, we have that specific local question, problem, whatever that we're faced with, and we look at it and we go, yeah, I don't know what's going on here. And then we start searching that general knowledge to help us explain it. but we don't have it yet. Nobody's figured this out yet, right? So we need to work the other way. We need to take this one thing, understand how it works so that we can make that general knowledge, that larger theory or law or just concept or whatever it is, so that it can then later be used for deductive reasoning, right? Like take fingerprints, going back to that, knowing that fingerprints are unique, that's not some natural thing. Like the first human didn't show up and say like, I'm the first human, and oh, I have these little things on my fingers, and I know that any of my future offspring will have different designs. Right? No, that didn't work that way. What happened was somebody looking at, their fingers. I don't know actually know how this came to be, but you can just, go with me here. Somebody's looking at their fingers, and they go, hey, look at them ridges. Right? Check out those weird lines. That's where, hey, you, come here. You got these lines? Yeah, you got them, but look, my goodness, they're different. That's that specific thing. It's just a simple question, and then you need to do the right testing to come up with that knowledge to be able to prove that, oh, yes, all fingerprints are unique, right? And it's, like family members can have stuff that look very similar, but still they are statistically different, right? So inductive is how we come up with those greater bits of knowledge that we can then use for deductive reasoning later on. All right, so we're going to focus on, for the rest of this lecture, we'll focus on inductive reasoning as I'm talking about the scientific method. But then also with, a lot of the other stuff we're going to be getting into, it's going to be deductive in that we're not starting from zero with everything. I'm going to be showing you, stuff like locally in Southern California, say, and that'll be that specific, but we'll take general already known knowledge to explain it. So we'll be doing a lot of deductive work here. That's what you guys will be, being exposed to. But it's important to get into how this inductive stuff works so you know how we came up with this general knowledge in the first place. Does that make sense? Hopefully. All right. So the scientific method, all this, lead up, what we're getting into is what the scientific method is, and it's this process, right? This systematic approach, step by step. That's what method means here, that we have a plan or a recipe or however you want to phrase it. And so it's inductive, right? What we're trying to do is to, come up with answers to these very specific problems with which we are faced. Okay? And so the scientific method, it's been effectively the same thing for hundreds of years now. And as I said, you guys have been exposed to this. And it's one of those things where, honestly, everybody kind of teaches it a little differently here and there. This was from a book that I used to use, and I simply use it because it's got this graphic thing, although I'll explain some problems with it in a bit. In my own stuff that I'm having you guys read, I've simplified the scientific method, or I've made it clearer and I think a little more professional, like how people actually use it, and also try to put it in just kind of more simple English. So read through that, and I think it's in chapter 1 where all that stuff is there. Go through that and realize, like, I don't get hung up on the actual phrasings of these things, or the steps themselves are all kind of more or less the same. So just kind of go with it. I'm not interested in you guys memorizing this stuff. I mean, I will ask you about like the first step, which is important, and the final step, which is important, that I'll be getting into here, that these guys leave off. But I'm not interested if you can memorize a list of, 6 or 7 things or whatever. What I'm interested in is that you understand like why we even worry about this in the first place, right? That's what we need to be thinking about. So in here, we've got, right off the bat, identify question. All right, that's step number 1, which is the most just kind of rigid, mechanical thing. Identify question. And that's not how people talk, right? How about just ask a question, right? That's what's happening here with science. And when you're starting to do inductive work as well as deductive work, to be honest. Anything scientific, anything academic, anything research-based in general, that first step is always going to be ask a question. Not identify question, ask it, right? And we all do this, or at least we should. But with science, if you're going to be good at doing science, or even just good at getting through college in general, you should be asking questions all the time. You should be a curious person. Are you a curious person? Are you curious person, student I'm talking to through these internet waves and all of that? You curious? No, of course not. You started out curious. We all did. That's a big part of humanity. And then so you were, when you were a little baby, oh, so cute, such a cute little curious baby, and you were curious about the world, and you wanted to explore and learn how things work and ask questions and all of that stuff. And then we beat that out of you pretty quickly. Right? We ain't got time for that. We ain't got time for curiosity. Don't be ridiculous. No, we do that, and it's at schools, and like I know, I'm a dad. I got kids, and they've gone through the elementary school system. In fact, my oldest, he just actually today, I'm recording this today. He just officially graduated from 8th grade, going on to high school next year. Super excited. He's a man now. But I remember back when he was in first grade, and I always tell this story to illustrate what's wrong with America. But my son, when he was in first grade, we got him into, my wife and I, we got him into a STEM school. Okay? STEM. What does STEM stand for? We just talked about it. Science, technology, engineering, and math. That's important, right? Why did we spend the time trying to get this kid into this new STEM school that was opening up near our house? Because, my God, STEM. That's the secret. If you have a STEM education, you're going to get a good job, right? You're going to be somebody. The rest of you, I pity you guys. Those of you who went to those non-STEM schools, well, I don't know, you just colored and did finger painting and all that. Oh, good luck getting a job, right? Probably not even talking to you because you couldn't make it to college or whatever. But if you went to a STEM school, there's somebody, right? You are special. Yeah. Yeah. No, well, it turns out STEM is garbage. And I know this because when my kid is in first grade, starting out there, he, it was a few months, I think, into the school year. And he comes home one day and he says, Mom, Dad, I got a detention today. First grade. I was like 6 or 7 or whatever, however old you are when you're in first grade. A detention. Did you ever get a detention that early on? I mean, what do, right? Even to get a detention that early on, you gotta stab somebody, right? I mean, you gotta do some serious, hardcore, freaky stuff to get a detention in first grade. That's ridiculous. It wasn't until high school that I got my first one. And even that, the teacher was uptight. She didn't know what she was talking about. But I mean, that's okay. Like, if my kids get detentions in high school, have at it, kids. But first grade, that's a problem. So, I get my dad voice on. I say, young man, that is not acceptable. Sit down and explain what you did. And so he sits down, this little tiny guy, and he just sits down and says, well, so I had to go to the bathroom, and I left the classroom and went out to the bathroom, and as I was coming back, I saw a worm, and the worm, he was on the sidewalk, but I know that worms don't live on the sidewalk, and they instead, they live in the dirt. So I watched him and observed him and wanted to see where his home actually was. And it's at that point, as a parent, where you go, oh my God, this is awkward. This is awkward right here. Because what happened was, so like my little boy scientist was out there asking a question and observing. He was 3 steps into the scientific method, right? But the teacher, I don't even remember. It was like Mrs. Hitler, I think. I'm pretty sure that was it's gotta be, right? What she does is she gets upset that my little boy, he's not filling out his worksheet or whatever, doing some god awful busy work, right? So she goes out and finds him because it's been too long, and she even knew what he did. Apparently, still gave him a detention, right? My God. And so, as a parent, you have to say, well, oh, all right, I hope you learned your lesson. And then, look over at my wife. I'm like, good, he's thinking. He's a scientist. This is what we want, right? So we didn't, we didn't get punished, except he had to stay in at lunch. And I don't, my God. Right? So he got in trouble for doing STEM at a STEM school. The point being that all this STEM stuff, this is why I get so mad about it, it's all garbage. It's all stuff to get, like, grants and, more tax dollars and stuff like that to get more funding for the school. And the kids are doing the exact same garbage worksheet memorization stuff that everybody's done, that I, had to do, that you guys had to do. All this stuff that just beats that curiosity out of us. And we've just become little computers, these little robots that just repeat stuff, right? So no, you're not curious anymore because it's been beaten out of you. And then you get into college and all of your professors are going to say, like, why aren't you more curious? And we all get pissed off because you guys aren't asking more questions and getting excited. And you're asking, like, is this going to be on the test and stuff like that? And we get really mad on this end, but we forget that, oh yeah, you spent the last 12 years of your life being trained to just behave that way, right? And be rewarded for that. So, bad news, everything you've learned up until this point, up until college, garbage. Throw it out the window. Forget about it. You're better off without it. And so now we're starting over, right? And so now, everything you do in college, you got to be asking questions, whether you're doing science or not. Okay, so that's the first step for everything. But in the case of what we're talking about here, it's the first step of the scientific method. Okay? Now, this image we have on the screen, so we've got our general process on the left there. Identify question, that's step one. So that's our steps of the scientific method. And then on the right, we have the example. These authors, they decided to kind of put it into, like a practical example. So you get how science works. All right? So their question that they identify is, what is responsible for apparently stunted trees in a grove? Yeah. You know what that means? What is responsible for apparently stunted trees in a grove? Why we got tiny trees is what it says. Stunted tree means we got all these normal trees, and then we got some tiny trees next to it. Right? What's the deal? Yeah, and this is from a geography textbook, and we wonder why we have such a hard time getting geography majors, right? Like all these other fields, you can, like, go catch bad guys or cure cancer or whatever. Or, hey, college students, if you want to finally get answers about them tiny trees, sign up for geography. All right? This is garbage. But I'm too lazy to make another graphic or whatever, so I still use it, and I like to mock these guys too. So, it's win-win. So we're going to go with the tiny tree problem that I know now that it's been brought to your attention, you're dying to know why, right? But it's the idea, picture, geographers are out hiking around in the forest and everything's great, and then suddenly they stumble upon tiny trees. They go, ho ho! They ask a question, what's the deal with these tiny trees? All right, now we all ask questions all the time. So just asking a question like, what's going on over there? That doesn't mean you're a scientist. You can't start, high-fiving and wearing a lab coat and all that. You're not really a scientist until you go on to answer that question or work to answer it, at least, right? So you're going to move forward and figure out what's going on. Now, in this example here, they have, like, gather information. And that's good. Really what that means here, it's like you ask a question, go just Google it, right? At this point, make sure nobody has answered it to start with. Okay, that's what we should be doing. So gathering information, you're doing your background research. If you're really serious about getting to the bottom of these tiny trees, you'd start, looking stuff up. Start, searching. Has anybody, answered this before? Because if somebody has this perfectly suitable answer for your problem, great. You're doing deductive reasoning. You don't need to go on and do this inductive thing. You're done at that point. You've solved it, right? But if you try to gather information and just nothing is out there, well, okay, let's figure it out. So if you see like, okay, we don't have an answer, then you move on to the hypothesis. Okay? Now, what does hypothesis mean? Perfect. All of you, exactly as I expected, shouted "educated guess" into the into your phone or your computer or whatever. Right? Is that what you said? You said it, didn't you? Educated guess. You don't even know what that means. That's what's so sad. And it's all this STEM nonsense. It's all this making you memorize stuff. All you had to do to pass third grade science or whatever it was, where this is first introduced, and then later on in seventh grade, and then junior year, like whatever. The thing is, when the question was, "What is a hypothesis?" As long as you wrote "educated guess," you got those points, right? High five, move on. You're a scientist. It's nonsense. What does educated guess mean? And I defy students all the time to define that, and they struggle because we never question it. It's just that thing that we memorize. Okay, a hypothesis. What we're getting at is we're predicting. Okay, we're coming up with a solution to our problem. We're predicting what the cause is, but a key thing here is it's got to be testable. Okay? And that's something that educated guess doesn't get into. And so educated guess, really, we're guessing. We don't know anything when we're at this hypothesis level. We have this guess, right? Now we're going to try to be intelligent about it, form an educated guess, meaning we're not going to say aliens, space monsters, what wishes. We're not going to do that kind of stuff. We're going to gather information and we're going to try to, based on all the known information, piece together a very logical, plausible way to explain what's going on. In this case, our tiny trees. Okay? But this thing, it's got to be testable, meaning, like saying, like, they're tiny because a genie made them so. Like, how do you test that? Right? Are you going to find a genie and question the genie? No. No, what you got to do is you got to have something where you can, in fact, test it. Right? Gather some data, run some analysis, experiments, like whatever it might be, test your educated guess, and then see, was it correct or incorrect, right? That's the idea. And then here too, this is a problem with this diagram here. It says form a hypothesis and then generate predictions. Honestly, that's the same thing, right? Your hypothesis should be your way of generating a prediction. So they're saying here, low soil acidity won't allow nutrient uptake. All right, back to pH. See, this is how sexy geography is. It's all about how acidic or non-acidic something is and what makes our tiny trees. We talk about more stuff. We're going to get into death and destruction and terrifying stuff and sexy stuff later on. But for the meantime, dirt pH. That's what we're looking at. So they're saying, hey, this dirt pH is not right. So we got tons of plant food for these trees. They should grow up to be big, healthy, strong trees, but they can't get that plant food that's in there because of the pH of the soil. Now that right there, that's a testable prediction. We don't know, number one, if that's true or not. It's an educated guess, if you want to phrase it that way. But it's something testable because we can go out and we can test the pH of soil, right? Like near where these tiny trees are, as well as where the tall trees are. We can also measure the amount of potassium and nitrogen and all the plant food and stuff that's in the soil. And of course, we'll also map it out because we're geographers and we're conducting spatial analysis, right? So quite often what we're doing is we're not only gathering data, but we're mapping stuff. And so here's another thing. I'm just getting angrier as I go down here. This whole design and perform experiment step, the light blue one, that nonsense. I hate that term experiment, all right? Because it makes me think of, chemistry. And no offense, chemists, bless your little hearts. I love the way that you chemistry students, go in and you boil water. And you go, yep, it still boils. All that, like that's sweet. That's a cute little experiment that you do. But experiment. That just, again, conjures up images of people in lab coats stuck in a lab, boiling water, and just going like, eureka, and no. No, it's not what geographers do. We don't experiment. I mean, you can in geography, sure. And there could be plenty of physical geographers who would hear me saying this and say, "You're a moron." I'm sure they do. That's fine. Because I'm making fun of some of them right now with this diagram, so that's fair. But no, we're not experimenting. What we're doing is we're going out into the world. We're gathering data. We're sampling data. Okay, meaning that we're not going to go out and look at every single tiny tree in the entire world and every forest or whatever. But we're sampling stuff. Usually, we're covering large areas, so we're taking. There's a lot of statistics involved here, spatial statistics, to make sure that we are gathering the right data to get our stuff. And so we're getting all the data and we're mapping the data to turn it all into information, to get a sense of what's going on. So this would be very easy to map. Go out into the field, like I said, record that pH, the different nutrient levels and stuff like that. We'd map in where we got tiny trees and where we got normal trees. We overlay all that, in the computer and some digital map. We'll talk about how that stuff works in the future, maybe the next or another lecture from now or whatever. We'll get into some of the mechanics of that stuff. But we'd map it and we'd look at it and we go, aha, yeah, what's that low? Look at that pH here. It's much lower here, and what I don't even remember exactly what our hypothesis was at this point. But it's the idea, we could go, yes, our hypothesis was correct. It was true. We solved it. So it's no longer a hypothesis. We've actually proven it. It's now scientific fact. Okay? That's what we're working toward. Now, there's, of course, a possibility that we can then go and we test this stuff and we find out, oh, our hypothesis is wrong. And that's fine. That's actually, if you're not having your hypothesis, proven incorrect, at least, a few times every now and then, you're not asking the hard questions. You're not doing good work. Like, that's a great thing about science, and not just science. I mean, I'm talking all this science stuff. I do more human geography. I'll get into that in a little bit too. I started out doing a lot of this more physical stuff, and it was fun. And if that's what you dig, then like go for it. But I like more of the human stuff, the messier questions and all that. But I love that. Like, I'm wrong all the time. There's stuff that I thought I understood 5 years ago. I'm like, yep, that's how this works. And then I keep, gathering more data, keep testing more stuff. And I go, oh, no, I was wrong. I was quite clearly wrong. But what you do is you go, yes, I was wrong. You admit it, and then you go back and you refine, come up with new hypotheses to explain whatever it is you're studying, and you keep working until you prove it, right? Until you get something that sticks, until you actually figure out the answer to whatever that problem might be. So down here, this whole analyze data, evaluate hypothesis, you're just saying, hey, did I get it right? Or did I get it wrong? And if you got it wrong, just go back, keep working until you get it right. Okay, that should hopefully make sense here. Now, we're going to get into the final step because they leave off something big here. But the idea is, as you're going through here, with scientific research in general, we tend to get into this whole idea of a theory, right? A scientific theory. And theory is a very fuzzy word. Like, it has a specific meaning, but we never really use it properly. People often conflate it with hypothesis, and they don't use it properly. And they kind of switch the two and all of that. But to be honest, like, we are working toward theories and a lot of what we do in geography and other sciences, in the academic fields and all that. We want to have some thing that works here, but that's not necessarily what we're doing with this one single experiment process, like whatever it is you're doing, right? Your data sampling, your any little bit of scientific stuff. Usually what we're working toward is a little bit of information that will hopefully go on and inform a larger theory. Okay, so a theory, a scientific theory, it's an explanation. Okay, it's a way to explain why something is the way it is. Right? That's the idea. And it's not a guess, not an educated guess. It's based on a lot of work. Okay? A lot of work that you've done, a lot of work that other researchers in the field have done. Okay? And so that's what we're working toward here. So don't fall into that trap where you say theory and you mean a guess, right? Whether it's a hypothesis or even an uneducated guess or whatever. Okay, so just keep that in mind. Don't be one of those people, right? So a theory is an explanation. Now that's different from a scientific law. Okay, so in science, a law, which sounds way more impressive, right? That's telling us what happens. Okay, so it's giving us the mechanics. Right? So a theory is an explanation. That gets into the why. A law is the what. Okay? And so we've got like the law of gravity versus the theory of gravity on the slide here on your screen. So law of gravity, we've heard about that. And really that just means, I hold up a pencil and I let go, it's going to fall. Right? That's the what. Hold it up, let it go, it's going to fall. And we'll get into gravity's a little more complicated than that. We'll talk about that. But then theory of gravity, that's fuzzy, right? Do we even have a theory of gravity? No, as far as I know. I mean, I'm not a physicist. I don't work in this field, but from what I know, unless something's changed, we don't know why we got gravity. We just do. So we know what it does, but the why it exists, that's a totally different thing. Okay? And so what we'll be getting into, like we'll talk about gravity, not the why, but we'll get into the what because it's important for other stuff we're more interested in. But we'll talk about the theory of plate tectonics, which hopefully you're at least vaguely familiar with, but we'll get into what that is. We'll get into the theory of natural selection, Darwin's theory, how we have all these different species around here, or why I should say we have all these different species around here. So it helps to explain this process of evolution. And at the very end of the semester, we're going to get into that. I'll spend time on it, explaining how we know this stuff, why it's a good explanation, and all of that. But quite often, people say, like, if scientists really believe in evolution, natural selection, all that, they call it the law of natural selection. But that sounds better, like you don't want to break the law, right? It sounds like official, but that wouldn't actually make any sense, right? Because it means something totally different. The what of something like evolution is less interesting than the why, as we'll see. So that's where we get this concept of theory. And again, that's something we're not going to have. Like, not every little thing you do is going to lead to some new bold theory. Okay? We don't just come up with new ones just like that, right? Like, theories are something where if you're lucky, you get to, over the course of a career, you can start to develop something like this. It's really, a powerful explanation for stuff, and very rarely you can have somebody that comes up with something so, monumental, life-changing, change the textbook stuff. Like, that's what the theory of plate tectonics is, and we'll see that's not even one person working over the course of a career. It's a lot of different people that were working together to come up with this mind-blowing explanation about all sorts of stuff around the planet. All right, so don't expect with every single, like, we're not going to have the theory of tiny trees or what. I mean, we can explain that one little thing, but it's not like, it's not an exciting, you're not going to be on the covers of magazines and all that. So yeah, we're not working toward that with everything we do. And honestly, a lot of the scientific work that's done, you're contributing just little pieces to the existing information, and you're trying to come up, with just more evidence for some greater answer that, we're looking for there. Either, adding to an existing theory or contributing to something that might eventually lead to some big, bold theory or something like that. But in order for that to actually work, in order to be able to contribute, we got to do this step. What I'm going to say is the actual final step, the scientific method, and that's publishing. Okay? Taking your work and getting it out there in the proper way. Okay? And this what blows my mind is that this idea of peer review publishing that I'm going to explain to you guys, it's how everything, whether it's science or academics in general, like whatever your major is that you're involved in, all the information that exists, it exists because of this publishing process, specifically this peer review process. So it's fundamental to everything in colleges, universities, all of that. Yet we never actually teach it. We don't explain it to people, to our first year undergraduate students. We don't. At least I never had it. I haven't seen it in any intro geography textbooks or anything like that. It was like later on in grad school where I finally, I think, was explained fully or was explained fully to me how this stuff works. Okay, so that's what I'm going to explain it to you. And so what we have here on the screen, we have a handful of these different peer review journals, or we call them professional journals. It means these are collections of papers, right, of scientific papers, or in whatever field that we've got here. So these are all just different examples of these things. So it's kind of like, you can kind of think of it as like a magazine or a little book, of different chapters or whatever. But it's very specific. And it's not anything you're going to find like outside of college. They don't, sell these things in Barnes and Noble or anything like that. It's very specifically geared toward universities and continuing knowledge and all that. So these different ones, these are all connected to geography and stuff we'll be talking about and all that. So it's examples of, good journals that exist. And so what we're going to do, like, let's say we're geographers. We just did our tiny tree study, okay? And we asked our question, and we formed our hypothesis, and we tested it, and it's true, and okay, great. Final step, we got to write what we did, okay? And this gets back to being verifiable and repeatable and all that. We got to document this stuff, and so we're going to type up a paper about what we did. It's a research paper, right? Like all these essays and papers and stuff you guys have to write in all your classes. What we're doing is we're teaching you how to do this kind of stuff, how to get published in an academic sense. And it doesn't mean, like, you don't have to be a scientist for that to be beneficial. You can publish this stuff in anything. If you're an English major or administration of justice or whatever, if you're doing it in an academic sense, what you're going to be trying to do is asking questions in whatever field it is, and directly related to whatever it is you're specialized in and all of that. But you're going to be testing stuff and studying stuff, and you're going to be writing it up like one of your English 101 papers. And I think that's another thing. I mean, I haven't taken the English classes here at AVC. I don't know. In fact, I should ask. I know a bunch of those folk, but I don't know if they say like, and you're learning this so that you can go on and do peer review publishing and blah, 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 blah. We usually say like, if you can't communicate, what good are you, or something like that. No, what you're being trained for in college, the way this whole thing has been set up, is to be good researchers, to be able to ask questions, solve these questions, and get that information out there. All right, so let's imagine well, this is weird because I usually say it's like like it's a whole class of 40 people or whatever. That works. But we can just, hey, you know what? It's just me and you, right? Yeah, you. I'm talking to you. The one listening to this. It's just me and you. That's got kind of creepy. So I'm going to try to backpedal from that. It's getting. Let's just say me. We are geographers, people of geography, and we went out. We were hiking and we saw these tiny trees, and we did all this stuff. We're going to write up our paper, and we're very proud, and it's got the nice introduction and explains what we did and why we did it. News and work in the past, similar, but they didn't quite answer this thing, and we'll get into our method, all this stuff. So we'll write that up, right, with the idea that we want to get this thing published. Okay? So we write this paper up, and then we're going to decide on a journal. You pick one that you're gonna go for here, and you contact the editors of that journal, and you say, yeah, I got this paper. I hope you guys like it, and they look at it. The editor's going to look at it and see if it's like, worth their time, if it even fits the journal, if it even seems like real academic work or whatever, because they can say, like, right up, like, sorry, this isn't for us, and they just reject it right off the bat for whatever reason. Okay, but if it passes that stage and they say, yeah, this actually might be a good one for this journal. It's got some merit for what we publish and what we're hoping to publish and all that. So there's definitely this human element here and this editorial thing. And honestly, if you get rejected from one journal flat out, you can just take that same paper, if you think it's still good, and you find another journal and try to do that. And it doesn't mean, you're not, doesn't like cheapen the science of all of this stuff. It's just, these things can only publish so many papers a year. They have specific things, their questions and stuff there. They're trying to have their journal, being at the forefront of solving and all that. So you go around until you find a good fit, right? And so if the editor says, yeah, this works, they then are going to take our paper, right, the one that me and you wrote, and they're going to take our names off of it. Okay, so they take our names away and they send it to, it could be 2, 3, 4, kind of varies on the journal itself and I think the field, 2 different disciplines. Typically with, like, in geography, we got like 3 reviewers that are looking at stuff. And so these folks, they're going to get our paper, again, without our names on it. And why is that? Why don't they want our names? It's bias, right? I mean, it's the idea we don't want, and especially with something like geography, it's a tiny field. We all kind of know each other, even if we don't know each other. Like, I know plenty of geographers just by name and what they study and all of that. I've met people at different conferences and so on. So, and I've got friends and I've even got enemies. As stupid as it is, but we all have that. It's how petty and pathetic we are. It's ridiculous, but I have geographers that I hate with a passion, and I hope I never run into again because it could get ugly. So it's the idea that if, like, my enemy gets my paper and they see my name on it, they're gonna right off the bat, they're gonna say, "Oh, it's this guy? No, reject it. This is probably, I'm not even gonna read it. I know it's garbage because that guy's a jerk." Yeah, it's that kind of thing. We're trying to avoid that, right? So we're trying to keep this anonymous to ensure that we don't have that problem of bias. And the reviewers themselves are also kept anonymous, and we call this a blind review. Okay? With the idea that the editor knows the identities of everyone, but for everybody else, it's it's about the work, right? That's the idea. You shouldn't know the person. Okay, that's what we hope for, anyway. And again, it's just to make sure it's all about the work and we don't let our petty little grievances get in there. So that reviewer is going to read through and they're going to make a decision, right? And these are kind of generic recommendations. Typically what we see is stuff like it's either, a publication as is, which means, hey, this thing is perfect. I have no critiques, no complaints. Publish this thing. It's great. And that never happens. I don't think that's ever happened. I mean, maybe you get some, people, experts in the field, like the rock stars in whatever field, they can kind of, get away with that. But even then, I highly doubt that ever happens in this whole blind review process. So you never get that. What you're hoping for is the second one, publication with significant changes. Meaning, look, this is good. The question is a valid one, right? This problem they're trying to solve, their methods seem good. They came to generally some good conclusions. I do have one issue, like this isn't clear over here. So explain this more. Or you said this over here, but that actually doesn't make sense. So, we can't say publish it as it, fix this. And if you fix this and I, read it again and it looks good, great, right? It's that kind of stuff. So it's that constructive criticism. And the idea is, we get sent back, and if you fix that stuff, then it'll get published, right? Or we can also have just complete rejection of the article, where it's like, look, this is not good. This doesn't make sense. It's incoherent. They start out saying this, and then they start saying this, and that doesn't even connect. Like, this is just not good. So, no, it should not be published. So, every reviewer, let's say we have 3 people reviewing our tiny tree paper, they're all going to, read through this thing, come up with their own, recommendations. They're going to have specific notes and stuff like that. They're going to send it back to the editor, and then the editor is going to take the consensus or break the tie or make that final decision, and then you get the information from there, right? That's the idea, okay, behind here. And so that way, if something goes through this process and it gets accepted, we know it's good work. Like if we're dealing with scientific, research here, we know anything that's made it through that blind review, peer review process, and it's actually published in a scientific professional journal, we know that's good science. We know that actually it fits the criteria. They did good work because we know that people looked at it without any bias and they realized that, yeah, this is great and all that, right? So if you're reading something, in fact, if I go back here, like if you're reading something from one of these journals, that's good stuff. That's gone through this review process. It's solid work, okay? Whereas if you find something else that hasn't been published here in one of these things, it's questionable, right? If that's actually, true or not. It's definitely not science, let alone is it, even, possibly true, right? So that's why this process is important. And it's something that hopefully you guys will go through as you go through. I mean, it is, I'll talk more about, some of these things and we'll see examples of them and stuff like that. But just this whole idea of doing research and getting stuff published, it's great. And it's awful. It's awful and great. It's the same. It's bipolar. Look, it's not a perfect process. Okay, it's slow. All right, number one. So things can take a very long time, and that's because stuff. It's all volunteers that are doing this. It's professors, people who are working as professors, teaching classes and doing their own research and all that. They will volunteer to do this stuff, or they'll get approached by editors. I just finished reviewing one of these things. I was happy to do that. It's actually I'm much better at it now because I'm stuck at home with all this COVID stuff going on. So that wasn't a big deal. I was able to get it, read through it, put in my recommendation, get that back to the editor relatively quickly. But in other times it takes a while because we have other stuff we have to do, right? So it can be a slow thing, and that could be a problem if you want to get real cutting edge stuff out there. And of course, you can have some things are slower than others, and for some papers it doesn't matter, and for other ones it is important. Like I just got one, actually, I just got it today, actually sent to me from a journal. And again, I'm a human geographer, so it's this paper I got. It's all about race, racism, Black Lives Matter. It's I just kind of glanced through it. It's directly referencing George Floyd and this, just everything that's going on at this moment. So as I'm recording this, every city's on fire. Like we're going through some stuff right now. So this one where it got sent right away. I'm going to try to read it as quickly as possible to get it back out there because it's dealing with this moment we're currently in. And if it's good, and I have no idea if it's good or not, but if it is, it should get out there, right? To get this very academic, well thought out, well reasoned information out to people, and people can trust it, right? Or if it's if it's not good, then sorry, try again. You tried a little too fast here, or whatever, right? So it doesn't always have to be slow, but it can be a pretty slow process. We can also have what really gets to be a problem is when we get into conflicting views, whether it's theoretical stuff or personal stuff or whatever, and we're not supposed to do that as we review things, but it happens because we reviewers are human, and so you get something and you're reading through it and it just bugs you for whatever reason. You have to be careful. You don't want to let your own personal issues get in the way of the work, right? But it does happen. And it's a problem because the people who get stuff, like I've written about race and racism and study this stuff. And so that's why these people contacted me, because I have stuff out that kind of fits. So I know this stuff about which this article is about and all that. I've spent years studying it and reading stuff and all of that. But it can make it tricky because I'm invested in it and I have my own attitudes and thoughts. But I need to be open as I'm reading what this other author or authors wrote, so that I don't just kind of I'm not some cranky old man, right? That's what we're trying not to do. And I do, believe me, I try not to do that. And one reason why I try not to do that is because I've had it done to me, and it sucks. This is some of these awful things happen. These just cranky people who just tear your stuff apart. And I've had like editors say, like, okay, look, this guy's a jerk. He's missing the point. Just could you try to make him happy, make a change here too. You don't have to change the whole thing, but just change it. And I've done that, and it's stupid and it's human and it's messy, but it's what we got to do. And it's not a big deal, right? The only issue we really have with the peer review process, and it's not just the peer review process, it's just life in general. The only issue we have is fraud, right? Where somebody publishes something that is an outright lie. Okay? That's a problem. Now, sometimes it's not even a problem. Like, you've had some people who have done this stuff where they type up a purposefully fraudulent article just to see if they can get it passed, through the editorial process. They're trying to make the journal look stupid. And these people look stupid. There was a study where some people did this with like gender studies stuff, a few different journals, and people got their stuff published. And then they, as soon as it got published, they said, "Ha ha, we made the whole thing up, and you guys are stupid." And really, it's just those people who did that, they were just being assholes. And the whole thing, it was a whole thing. But whatever. Okay, it's not the end of the world. It doesn't fundamentally, change the foundations of science or anything like that. But every now and then, you'll have stuff where it's an outright lie, and it's because it's somebody doing the research who isn't the most ethical, who isn't a good researcher. Like, there was a number of years ago, there was some guy, he published something, he was an anthropologist, he studied like monkeys, and he published something about like monkey facial expressions, and he lied about it. Can you believe that? I don't even remember exactly what he did, but he said, like, yeah, when monkeys are scared, they look like this, and it turns out they don't look like this, or so. It was so stupid. So that got out there, and it was just, the guy was desperate, and he was trying to get tenure at a university, and you have to publish so much to get tenure, and so, he was really desperate to try to keep his job, and so he lied, but again, so he lied about monkey faces, like, yeah, okay, whatever, okay, so that's not an issue, but then there's some stuff every once in a while, and I mean like once every, 20 years, 30 years, something like it. It's a once in a while kind of thing, if that even, maybe even longer, in terms of how often it happens in between these events. But you'll have something that really screws up society, all because somebody lied to get something into a peer review journal. And I'll explain it. Okay. Like I said, I have kids, right? You guys got kids? You got kids? If you don't, get some kids. Homework assignment, go make some babies. They are fantastic. They are wonderful-ish. They got issues, but just a little baby. Oh, babies are so cute. And just when they're so tiny and new, not when they're screaming, and in the middle of the night. And my wife dealt with most of that stuff, because, I couldn't feed them. But still, just to hold a little cute baby sleeping, wonderful. So babies are great. Go make some babies. It's not really, okay, it's not really, I realize too, I'm talking into my computer. I'm not talking into a classroom full of people, so you can't see my face that is saying, don't go make babies, be safe, wear a condom, don't really do it when I say something stupid like this. But I'm going to ruin the joke, because you can't see me, and I'm worried that, like, 2 or 3 of you are going to go out and get pregnant and expect me to pay for the kid or something because I told you to Look, don't make babies until you're ready. But when you're ready, oh, make a bunch, get a dozen babies. They're just fantastic. And so here's the deal: the whole like, and even the baby, like I love the pregnancy part, right? That which is a bold statement for a man to say. I know, yeah, I love when a woman was carrying my child and I had nothing change in my own body, whatsoever, right? Like don't ask my wife; she would probably talk differently about this stuff, but still, it was just fun and exciting because there's a little human being in a stomach, and you can't see the little human, but you feel like the kicks and the punches and all that, and you're like, oh, what's this kid gonna be like, right? And all that stuff, and then it's time. You get for in my case, it was always after I had spent a whole day like teaching like 3 classes, got home late, exhausted, had to be at work, and actually just trying to sleep, and it was like 1 or 2 a.m. Getting an elbow in bed, like it's time, and then we had to run to the hospital, and get ready to have the baby, and all the breathing, and all this stuff, and then finally it's go time. Baby shoots out, right? And yeah, I mean, I'm not a doctor, right? I mean, I am, but not that kind. And so the baby shoots out. I think is the technical term. And you got the nurses there who are really doing all of the work. The doctors just kind of sign papers and stand there to make it look official, but the nurses are doing all the amazing stuff to just make sure this baby is living as it comes into the world. And so, like, they get the baby, they scoop it up, like you cut the little umbilical cord, and they start warming it up. They put goo in its eyes. Yeah, I didn't even know what this was until I started having babies. But it turns out they put this goo in the eyes, and it's for something like it's like for gonorrhea or chlamydia or what. It's like just in case mom is rocking some STDs, like that could make the baby go blind, I guess. So they don't ask mom, like, hey, are you, full of STDs? They just put the cream in the eyes. They assume every woman is just riddled with disease down there. And just, to be safe, they put cream in the eyes, right? And yeah, try looking at your wife the same way after you see the cream rubbed in the eyes when you know what's going on, right? But yeah, they do that. And that's like all this scientific stuff. But then they want to start, taking a little bit of blood to test that. And then also there's this whole idea with vaccines, right? We want to make sure that the baby is safe from scary diseases, spooky diseases, stuff like that. But wait a second. I mean, yeah, I don't want my kid, my cute little perfect wonderful baby with the smashed face, because it's been through some stuff, getting out into the world, right? And eventually that face pops back into position, so it's okay. But it's wonderful, perfect little baby. This is a little tiny version of me. I want the best for this kid. I don't want this kid to get some horrible disease and die. But I've also heard that if I give them the vaccines, it could do something to their brain, right? Like this could, like autism. That's why there's this thing. I know I've heard that with vaccinations, it doesn't necessarily always happen. I mean, I've been vaccinated and I'm not on the spectrum, so it's not definitely a sure thing. What I've heard is that yeah, there's a much better chance that your kid is going to become autistic. Is going to be on that spectrum, and there's nothing wrong with that. I should point that out. That like you can be autistic and have a wonderful life. Like it's not an awful thing necessarily. There are some cases if you're on one end of the spectrum, it's life is much harder than on the other. But like we'll talk about Sir Isaac Newton. I think next time we'll get into him. There's a lot of speculation that he was autistic because he was just his brain just didn't work the same way as a normal human, and that's why he was so brilliant. So being autistic isn't awful, but at the same time, as a parent, you want your kid to just not have any hardship, right? You don't want your kid to have to overcome this or that or whatever. You want their lives to be as easy as possible, but at the same time, they don't grow up to be jerks, so, whatever. So yeah, do you let them put this needle in your perfect little baby in the hope that they don't get, measles or whatever? Or do you say, hey, let's hold up. Let's just keep the kid away from disease. Just, we'll be better off, right? That's an issue. Except here's the deal. It's not an issue at all. That's bullshit, right? And the reason why we can say that is that it's because we know it's not true. And the only reason why people think it is true is because of a fraudulent peer review study. That's what all of this goes back to. Okay? One guy who lied about the connection between autism and vaccinations. Okay? Complete lie. Now we know it's a lie. And it was back in the 90s. And so this guy, a doctor, medical doctor, publishes in a very prestigious medical journal, goes through the whole peer review process. He publishes this study that shows a link between vaccines and autism. Okay? Everybody freaks out, right? Because that's a big thing. Like, is this medicine, this inoculation I'm putting into my kid, is that actually going to make my kid, worse off? Am I doing more harm than good by doing this? So as soon as this gets published, and yeah, it gets published because it seemed, very legit, and it was, verifiable in the sense that you saw what the guy did. You assumed it was repeatable, but we can't, necessarily go out and instantly repeat a study that has allegedly taken years to be done. So it gets published, and everybody freaks out. It hits the mass media. Everybody hears about this, and we start to see this whole anti-vaccination movement. And at first, it was the idea that there were chemicals put in some of the vaccines that weren't safe, and then we got rid of those. And then other people said, like, now it's just vaccines in general. I just don't trust what the government wants to put in me, which is, I can't totally, argue against that. You shouldn't never fully trust your government. But it's still, we need to have this critical thinking, right? But it's a case where, yeah, like, we still have this article out there, this science saying there's a connection. The problem was people started to try to repeat this and wanted to keep studying it to get more answers based off of this initial work. That study couldn't be repeated, right? And nobody could do any other kind of study or find any other link between autism and vaccinations. And it's because this guy lied, right? He was trained, he knew what he had to write to make it look like there was a link, and he believed, in fact, he still believes to this day, that there is a link between these things because his own kid developed autism at around the same time that he got like the measles, mumps, rubella vaccine. Okay, and so the kid gets the shot at the doctor. Not too long after that, starts exhibiting signs. I don't know exactly what the whole story was, but so this doctor, the guy who wrote this, thought, okay, I know, even though I haven't proven it, I know there's a link between these two things. So he, kind of did his own study, but it was garbage. What he did was, like, his kid and his kid's friends, he sampled their blood at like birthday parties or something, right? That's some creepy stuff, right there. If you ever had a birthday party and the dad asks you for blood, run, get new friends. Like, don't put up with that. And so he sampled like 4 kids, 5 kids, something like that, and decided there was some link or whatever. In his paper, he upped that number because nobody could do that. Nobody could study their kids and their kids' friends and say, like, aha, I've discovered this scientific truth. No. So he, bumped it up to hundreds, thousands of children or something like that. So he flat out lied. And so as people tried to continue this work, realized it didn't, there was no link, it wasn't showing up, and it eventually came out that he lied. And he admits he lied, even though he still, as I said, believes that, there's a link. Because he feels there is, right? That's not science. And that's fine to have, a gut feeling and all that, but we can't let that get in the way of what's supposed to be empirical scientific research, unbiased scientific research, right? The problem, though, is even though I can tell you that no, there's no link whatsoever, it's still out there. People still have that feeling, and that's the problem. And kind of the great thing about being human, let's be honest, like, we're not robots, right? We don't take in fact and process it, in only one way, and we come up with the best possible solution, and we, move about, with our fellow robots, and everything just works in that purely scientific way. We're messy and stupid, and we do all sorts of things that make no sense whatsoever, but we like to do it. Right? Or we do it whether, smoking or drinking or eating fatty foods or having too much sugar, stuff like that. I mean, those are great examples. We all know what to do, in order to be healthier people, to live longer, to feel better, all that. Do we do it? No. That food tastes so good, right? Or that beer tastes so good, or like whatever it might be, right? So we're messy folks. So we know scientifically there is no link between vaccines and autism, but we still have people who refuse vaccines. And like if there is a coronavirus COVID-19 vaccine that, comes out onto the market, plenty of people have said they're not going to take it because they just don't trust vaccines. Right? Even if there are no scientific studies that have shown, a reason to be afraid of this. In fact, even if it's the opposite, where there are plenty of studies that say, yeah, you take this, you're going to be safe, and if you don't, you're going to die. People still don't trust it, right? And that's a problem, and that's a little, chink in the armor of peer-reviewed scientific research, but it doesn't mean that this stuff isn't still the best way to get new information. Okay, keep that in your mind, right? Like that, we still want to look for the peer-reviewed information, but we also, as always, we want to be thinking about it critically. Question what's in there, but do so with, some kind of scientific backing. Don't just look at something like, yeah, I know some fancy smart person said this, but I don't like it because it makes me feel funny or whatever. No. Do your own research, ask your own questions, and all of that, right? So that's the idea. So still, this is our final step. This is the best way to get scientific information, knowledge out there into the world. This is what you want to be looking for too. As you get more information about whatever, that's out there, look for the peer review stuff, right? Look for from where this is coming. Did it come from an actual university or big hospital study? See if you can find that original thing. That's something I've been doing, over the past few years, is like you'll read something, some like online news source, like, CNN or the New York Times, or somebody will state something in a study, from researchers from blah, 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 they found out this. And they'll have a link even now, and you can click that link, and quite often that link doesn't even take you to the original study. It takes you to some press release or some other thing. And it's only in there, you have to click something there, and then it takes you to the actual study, right? Take that time to go look at that study. Make sure that the journalist actually understood it properly, number one, right? And number two, like, from where is this coming? Is it a real, legitimate peer review source, or did it come from some kind of weird, blog website thing that some guy put up? And, that's the idea. That's what you need to be checking for. Does that make sense? All right, good. Now, bias. Talked about this already. And bias, it's that idea of where we have, it's prejudice. It's this idea that we have some kind of notion in our head of what we like, what we don't like. And the idea of, prejudice, prejudge, it becomes a problem when we allow it to get into our brains, and where we don't take in new information, or we don't critically think about stuff. We just go, oh, I don't like that, and this seems like that, so I'm not going to like it, even if I don't really know what it is, right? We get that. And so with science, the whole goal is to be unbiased, to not have these, value judgments already in our head that kind of cloud our judgment on this new thing or whatever, right? Clearly that doesn't work. Like the autism vaccine guy, right? He was biased into thinking there was a link, led him to, lie about work and cause all sorts of damage to the just, public in general. So clearly he was biased, and that's an example of a bad thing. But then, the bottom of this slide here, it says, should geography be unbiased? And it's even italicized, so it's like, oh, there's something going on here, right? I don't know, what do you think? Should it be unbiased? I mean, I just kind of said, like, science should be unbiased. And, yeah, okay, I know you can't actually answer, or I can't hear you. We don't want to let bias get in the way of the work we're doing. So when we're actually looking for answers, we want to be as unbiased as possible. We want to do the good work. But here's why I love geography. This is why I stuck with geography. I don't know. I think I mentioned this the last. Like I have my initial degree, my bachelor's degree is in anthropology. I did the archaeology thing to begin with. I still, enjoy some of that stuff, and I'm going to talk about in a moment. The idea of field work. That's where I really got my love of that initially. But what I love about geography and geographers is that they'll be as unbiased as possible during the actual work. But if they discover something that sucks, oh, they're going to tell you, right? So they're going to, you're going to start to get biased as hell once you've done that work. Whether it's, like in this class, we'll be talking about climate change. That's the big one. That's the big thing that sucks, right? I'll be spending time talking about that. So I'll get into like all of the scientific stuff that I get into about how climate change, works, what the greenhouse effect is, how we know that the climate is warming and changing and all of that stuff. That was all done in an unbiased manner. Like that's good science. If it's not, I'm not going to be teaching it to you guys. And that's been the years I've been teaching this stuff. I've been going back, especially in the fields where I'm not like a perfect expert in or haven't, didn't have that much of a background. I would go in and make sure that I wasn't teaching the possibly biased kind of junky science or whatever, that I was getting you guys the real scientific stuff. So all the facts that I'm throwing out at you, the scientific concepts, that's the good stuff. But what we used to do, this was especially big like back in the late 90s, early 2000s, when really people started getting really vocal about climate change. A lot of politicians especially would say like, hey, scientists, just do your work, but I don't care how you feel about climate change. You just study it, right? We'll talk about feelings or how we're supposed to interpret this out here, we politicians. It's nonsense. And what geographers do, and this is what I love, is that they don't just like do the work and just like, well, that's okay, that's how it is. No. If we figure out that through our own human actions we are destroying the planet, we will say, hey, you morons, we are destroying our world. We are making life suck more, and we don't even realize it, and we need to realize it. All right? So we will yell at the world about this stuff. Some geographers are much better at yelling than others. Some make a lot of enemies. Some actually can yell in a way where you appreciate them yelling at you. I don't know where I fit into this stuff at all. But it's the kind of like, I'm going to tell you what sucks, what's good, stuff like that. But it's coming from that unbiased work. Hopefully that distinction makes sense. And the same thing with like on the human geography side. Like I already talked about, racism, poverty is another thing at work here. In fact, I'm getting ready. Like, so I'm recording this in June of 2020. I'm looking forward to teaching my cultural geography class in the fall 2020 semester, because there's going to be a lot of discussion about the rioting and the tear gassing and the racism and the police brutality and all of that stuff. And it's going to come from a place where I'm going to be getting into, empirical fact. I'm going to be unbiased in bringing these facts to the students. And, at the same time, once those facts are out there, I'm going to say, and this is why this sucks. And this is why we should change this and this and that. We geographers love to let you know how we feel about stuff, which you might not get in other classes and other disciplines. So just keep that in mind. All right? And hopefully you will, like I do. You'll appreciate that. Because don't you want the people who actually study this stuff and understand it more and better than, so many other people? Don't you want to hear their opinion rather than the people who don't really study it but kind of have, opinions for whatever reason? Yeah, I'd want to hear from the experts. So, well, that's what I mean by this right here. All right, now to wrap this up, so I've been rambling for a while. I just want to finish up with this idea of doing science and this idea of field sciences. I want to stress, not every scientist works in a lab. All right, I've done very little laboratory work, stuff that would be considered to be a laboratory. I mean, I've done some professionally, and we'll, talk about that here and there. But a lot of what I've done, in terms of going out and gathering data, it's actually going out and gathering data. It's been heading out into the wilderness to, to figure out whatever. And it's a great thing, right? It's fun. And and one thing I want to stress too is that you can make money doing this. You can support yourself. Like, you shouldn't go into any field science, um, whether it's, like environmental biology or geography or, anthropology or that kind of stuff. You shouldn't go into it thinking like, I'm going to make millions of dollars, because you're not. But you can be quite comfortable. I'm not going to have a fleet of Porsches or whatever, but I don't want a fleet of Porsches. I don't even want one. And that's because, honestly, it's because I like to do this other stuff. This is some field research right here. Like, you can't take a Porsche up here. This was like the last big project I worked on. This is the Rubicon Trail in Northern California, and I was studying Jeeps and Jeep people. And I say studying these people. I was in a Jeep taking this picture right here. I was having super fun being a fellow redneck as I'm studying rednecks in their natural environment. So it's got that kind of human geography component, but it's also, I'm connecting this idea of driving Jeeps into the wilderness and connecting it to climate change and just environmentalism in general, and saying, like, can you do only one of these things? Can you, like, drive a Jeep and care about the earth, or not? Right? And this gets back into what I was talking about with being an environmentalist and what that means. But I want to point out, like, this was my job, right? This is what I was doing. I was out playing. I even got paid. I got money to go do this, right? That's fun. Good luck, business majors getting paid to do stuff like this. Yeah, come on, sociologists. Where's your cheap fun? Huh? Yeah. So I mean, this is good stuff. And so I say this, A, to make fun of you and your choices, but B, to kind of show you that there's a career to be had here. And you could also look at this and say, like, oh, that's very rednecky. I don't want that at all. But you don't have to do that. Like, there's a variety of stuff. Some of this stuff doesn't even have to take place in the field. It's another great thing with geography. You can study whatever. In the left here, we have the Negro Traveler's Green Book, which was this field guide, a travel guide for African American motorists, people who were driving. Do we have the date? Yeah, this one's from '56, right here. So this is pre-civil rights era stuff, right? This is people driving, during the Jim Crow South, and even like here in California, we didn't have Jim Crow laws, but we were racist as hell as well, like every place was. And so this book, it was a list of places where you could be safe. If you were a black driver driving into a new area, you wanted to be able to, okay, I can stay at this hotel and I'm safe. Or it had a list of the towns where you didn't want to be after the sun went down, that kind of stuff. So it was a reference, right? And that's something I wrote about before there was the movie and all this stuff. And this was kind of one of those ridiculous things. Yeah, and this is, again, this is geography. It's more of a human geography thing, but it's place and space and spatial relationships and stuff like that, right? And me, I mean, like a classic white guy. If you haven't seen my picture yet or whatever, white guy, right here. I realized that, like, I discovered this book in the same way that Columbus discovered America. Like, I wasn't a hero or whatever. It was really what happened, and why I wrote about this was because I did come across one of these things in a museum, in this exhibit on Route 66, and I saw this and went, oh God, I had no idea this existed, right? And it was more of a, like, I was embarrassed for myself that I didn't realize. Like, my whole thing was like, oh man, I love the movie Cars and I love Jack Kerouac and all this, like, road trips are the best. Never once possibly thinking, oh, you know what? I love this stuff because I'm a white guy and I can drive anywhere and I can do whatever, right? This was my writing about this was my own encounter with this idea of white privilege, which I know a lot of white folks, they hear that and they go like, oh, that's nonsense. I don't have any privilege. No, you do. If, like me, I could drive anywhere. I've got my, again, this is really what I'm saying is you guys shouldn't have taken this class. You should take my cultural geography class. Usually in there I talk about my encounters with the LAPD, and how really it's been nothing but great, because they just, ignore me, wave me out, like, whatever, right? And it's because I'm a white guy, And I know if I didn't look like this, it wouldn't be the same case, right? And so I tell a lot of those stories there. And that's what I'm getting at. So that was something I studied and got to learn. And again, this is all part of my job. We also have down in the lower right that hopefully you recognize, one of the finest, geography films ever made, Mad Max Fury Road. Studied that, which means I got to watch that movie a few extra times and think about how it's connected to climate change and cars and stuff like that. I mean, that's what you can do with a geography degree. You can do anything. So look, hey, do whatever you want. Do what makes you happy, right? Like if you want to take whatever major you have that isn't geography, you go for it. I'm sorry, I just fell asleep thinking about your future and how boring it's going to be. No, if you want to do stuff that's actually cool and exciting and fun and constantly challenge yourself, you got to work anywhere, but like do things that are really cool. And don't worry, this is the last time I'm going to talk about this stuff. But getting into, like, did you know geographers found Osama bin Laden before the CIA did? Did you know that? And SEAL Team 6 and all that? Yeah. Yeah, not even just geographers, UCLA geographers. We'll talk about it. I'll get in it. We do it all. We save the world. We watch cool movies. It's fantastic. But no, you go ahead. You keep, you keep at it. That degree that you have, that psychology or whatever. All right. Pep talk over. You do you. Don't let me tell you how to live your life. But geography's so good. All right. There you go. So hopefully you get a sense now what science is, what it isn't, what geographers do specifically, and all that. Next time, we're going to get into geodesy, which is we're getting into what's on the planet and the shape of the planet and that kind of stuff. This is the good stuff. This is some good, hardcore geography. So get ready for it. Get excited for it. We'll talk about that next time. In the meantime, have a lovely day or night or whatever. Stay safe. And I will talk to you the next time I talk to you. All right, bye.